All right, good evening, everyone. These are your notes for Wednesday's class. These go on page 101 of your EN. It's chapter blue 4.5, and we are finding the pattern in sequences. Make sure you also put a date on your notes. Many of you have been missing that. Your essential question: describe how to find the pattern in the sequence 1, 4, 16, 64. All right, tonight we're going to talk about whether a sequence is arithmetic or geometric. I want you to practice saying those words, arithmetic and geometric. The easiest way to remember which one is which is based on, oops, I didn't mean to draw a diamond there, is based on which one the pattern follows. So if your pattern from step to step is a repeated addition, it adds the same number every time, then that is an arithmetic sequence. So we are going to define arithmetic sequence. Now this is a hard word to spell sometimes. Arithmetic sequence is a sequence, and it could be either repeated addition or repeated subtraction each time. Alright, a sequence with repeated addition or subtraction as the pattern. Now, geometric is the opposite. A sequence can only be one or the other. It cannot be both. It's either geometric or it's arithmetic. So if an arithmetic sequence is repeated addition or subtraction, I'll give you one guess what you think geometric is. Yes, you're right. It's a multiplication or division sequence. So it's a sequence with, and that's just shorthand for with, a W and a slash. Alright, so geometric sequence is a sequence with repeated multiplication or division. Now with both of these, the more popular pattern is going to be addition and multiplication rather than subtraction and division, but you will sometimes see subtraction and division. And for it to be an arithmetic sequence, it has to only be one. It can't be like add 2, divide by 3, add 2, divide by 3. Those aren't an arithmetic or a geometric sequence. Those are just a pattern. To be an arithmetic sequence, it has to have the same repeated addition from every single term. It has to be add 7 every time, or add 6, or add 3, or subtract 4. Or it could be multiplying by a -6, and then that would make it a geometric sequence. So we are going to look at a couple, and we're going to identify them as geometric or arithmetic. Now I'm looking in your textbook on page 242. So sorry for all the interruptions. Sorry for all the interruptions. I'm still at school, and it's after school, and they keep calling students down, so we kind of keep getting interrupted here. All right, so on your chapter 4-5 in your blue book, page 242, we're gonna clip this table out, and please don't take a pair of scissors and cut this out of your book. Alright, that would not be good. Alright, we're looking at this sequence, and we can tell from looking at it that we have 4 numbers in the sequence, and they're in positions 1, 2, 3, 4, because they're first, second, third, fourth position. And we can see that our numbers are 2, 4, 6, and 8. Make this a little bit bigger for you guys so you can see it. Hang on. Alrighty, so we have 2, 4, 6, and 8 as our terms, and we can look and see that to go from term 1 to term 2 is going to be a +2, or it could be times 2. And we want to write down both because we want to make sure we've tried all of our options. Then we go to our next term and we see, oh, well, from 4 to 6, that's only +2. So it can't be the times 2 option. We know that that's wrong. And then from 6 to 8 is also +2. So I see that the pattern is repeated addition. And since it's repeated addition, the sequence is automatically arithmetic. So if you're asked what kind of sequence is this, you would say arithmetic. I am hoping your notes are a little bit neater than mine. I'm not having a good day today writing on my tablet. My handwriting's coming out really sloppy. Alrighty, let's do another example. Going back to our book, let's pull out our next sequence. I'm going to clip it right out of the book and make sure you're copying this too. Alright, we have 5 terms in this sequence. However, alright, so our sequence has 5 terms, and however, we are missing one of our terms, so we're going to have to figure it out. So our first term is negative 12. To go from negative 12 to negative 5, remember that's actually a bigger number because we're getting closer to 0, or it's getting warmer. If you think about really cold weather, that's going from 12 below 0 to 5 below 0. They're both really cold, but 5 below 0 is a little bit less of cold. Alright, so to go from 12 below to 5 below, it's going to be a difference of how much? You're right, 7. And to go from negative 5 to 2, well, you think to go from negative 5 to 0 would be 5, plus 2 more to get 2 above 0, so that's also plus 7. To go from 2 to 9, again, plus 7. So that means to get my last term, it's also got to be plus 7. So I asked myself, 9 plus 7 is 16, so my last term must be 16. Now I need to be able to figure out how to write a function of this. And we talked about this on Monday, and we talked about this a little bit yesterday. We want to write a function which has y equals something n. Something to do with n, whether it's 2 plus n plus 3, 3 times n, 9n, n's to the second power, something to do with n. We just don't know what. Well, the nice thing is, we've learned before, is whatever our repeated addition is what goes in front of the n. So since it's a positive 7, my function is going to be y equals 7n. And we can go back and test this theory and see if it works. Okay, so to go from 1 to negative 12, I would do 7 times 1, and I get 7. Oops, that doesn't work. It's supposed to equal negative 12. So that's when you go back and you find out what would be that 0 number. What is negative 12 minus 7? Well, or what number plus 7 equals negative 12? In this case, since it's a negative, 12 minus 7, they're both negative. I actually add my numbers, 12 and 7, I get 19. And I keep my sign, so I get negative 19. Or you could have also just counted backwards, 12, 13, 14, 15, 16, 17, 18, 19. So I find it's minus 19. So I've got to add that to the end of my function. Now, function is just a special word for an equation. So I have y equals 7n minus 19. Now I can test it. I can say, okay, 7 times 1 minus 19. That's 7 minus 19. 19 minus 7 is 12. My bigger number is the 19. It's negative, so I get negative 12. It works. So far, so good. Let's check it with the 2. I've got 2 and negative 5. So I've got 7 times 2 minus 19. And it's supposed to equal negative 5. So 7 times 2 is 14 minus 19. I have 19 minus 14. That is 5. 19 is my bigger number, so it's a negative 5. Yay, it works. So you keep checking just to be sure, and then you know you have it. Alright? If you need any additional examples, make sure you go read your textbook, example number 2 in your book. It's really helpful on this. And there's also an additional video that shows you how an example with a word problem. It's Professor Berger, so you know he's going to be funny talking about sit-ups. Have a great night.